Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will look again at the design of alternative graphic user interfaces to make your application stand out. This was our application at the end of the last video. We have created an application which has a dialog with a gradient fill in the main part of the dialog. This is a gradient fill on a graphics control. We have also created 7 hexagonal buttons on this control, which if the user clicks on one of them, it will generate a message box. This allows us to have a total of 7 buttons which could link to other parts of the application or other entirely separate applications. This is to give our application a slightly different look for a graphical user interface. In this particular application, we're only using 2 types of graphic for all of our buttons. Ideally, you would have a different bitmap for each button to allow the user to tell the difference between them. The other thing our application is missing is that there are no tooltips on any of the buttons. When your mouse hovers over a button, no tooltip appears. Tooltips are a very useful way of giving feedback to the user, especially where the graphic on a dialog of a button is not particularly obvious to them as to what it would do should they click upon it. So a tooltip will give the user a good bit of feedback to let them know what the function of that part of your application does. So that's what we're going to be looking at today. How can we add tooltips to these hexagonal buttons, so that when the user hovers over one of the buttons, the tooltip will appear. The other thing our application is currently missing is an icon for the application itself. There is no icon showing at the top left-hand corner of the dialog. Plus, when you look at the taskbar, there is also no icon appearing down here. So let's go and have a look at the code and we'll fix that first. The first thing we need to do is to put in a resource statement to pull in our icon. I have created an application icon inside the graphics subfolder. So if we put in resource icon and then, in this case, the name of our icon and the path to that icon. So we will see in the folder our exe now has an icon associated with it. However, if we run the application, we will not see an icon in the taskbar, and we will not see an icon on the dialog itself. So there's one more change we need to make. In the function in which we create the dialog, we merely need to put in a dialog set icon command. This takes 2 parameters, the first being the handle of the dialog, and the second, in this case, is the name of our icon as we specified in the resource command. If we run the application now, we will see the dialog now has an icon at the top left-hand corner. And in our taskbar, we also have an icon showing. So having got that out of the way, let's now go and have a look at our creation of tooltips. First of all, I'm going to create an array to hold the text I want on the tooltips. And here is the declaration of the new global array I'm creating to hold the tooltip text. So having declared this, we can now populate this from within the PB main function. So here is the definition of our array from 1 to the maximum number of hexes in our application, which at the moment is 7. And we're using the array sign command to set the value of each of our tooltips. So I'm putting a piece of text with a space at either end for each tooltip. These are going to be used to pop up on screen to allow the user to work out what the button actually does. So as we're going to be writing to a graphics control, we'll want to set the font we're going to be using. So we can create a new font in this PB main function. And the font we're going to be using is Courier New 12 point. And we're also setting a bold setting on this one. And after our dialog closes, we can then close off the font and free up the memory it uses. So we've also used a global handle for the font. We'll need to declare this. And there is a declaration of our global handle for the font. So now that we have that sorted out, how are we going to handle the popping up of our tooltips? At the moment, the event handler for our dialog is in here. This section is used to work out that something has been clicked on. The user has clicked on an area of the graphics control. And this function here, getHex, works out which of the hexes we've actually clicked upon and returns a value between 1 and 7. We can then use that value to work out what we do next. Are we attempting to exit the app, or are we attempting to do one of the other functions? While this logic works fine for our application at the moment, we want to do a little more. We want to work out where the mouse is over the graphics control at any point in time. So we're going to have to change how this event handler actually works. We're going to subclass it. This may sound complicated, but you'll soon get the hang of it. If we go to the initialize dialog section of the callback function, the event handler, you'll see in here we pick up the handle of the graphics control, and then we maximize the dialog. And there is a section of this callback function called WMPaint. This is where we fill in the gradient color and then draw the hex menu. So what we're going to do now is, rather than store the handle of the graphics control in a local but static variable, we're going to store it into a global variable. And we'll call that GHGraphic. And then as such, we no longer need this local static variable. So after the control handle, we need to put another line of code in. This is the one that will set up our subclassing. And this is that line of code. We're calling a Windows API function called setWindowLong, and we're populating another variable called oldGraphicProc. We're passing it a number of parameters. First of all, the handle of the graphics control, which we have picked up here. This is the Windows handle. We're passing it a glw winproc, it's constant, and we're using the code pointer command. As you will see from the help file, the purpose of the code pointer function is to obtain a 32-bit address of either a label, a sub, a function, or a fastproc. This return retrieves the address of this object, and the value being returned is the value of this function, GraphicProc. This is a new function we're just about to create. So let's go ahead and create that function now. And this is the skeleton of our GraphicProc function. This is a subclassed callback function. We're using 4 parameters here: the handle of the window, the message passed, and the wparam and lparam parameters. This gives us more flexibility. And what we're going to do in here is we're going to detect the mouse movement. And once we've detected the mouse movement, we can then work out which hex we're currently over using the function we already created called getHex. So we're going to have to create some local variables to allow us to keep track of all of this. And here are those variables. Naturally, we're using X and Y for the coordinates on the screen. We're then working out the width of the graphic view, the hex number we're going to be pointing at. We have a P location as a point variable, and we'll want to store the text of the tooltip. So here is the beginning of detecting mouse movement. We can pick up the X and Y coordinates quite easily here by using the low and high commands on the lparam value. I'm leaving these 2 lines of code in here, as you may want to use them within your own applications. But we're going to be using the same method we did in the previous video to work out which hex we're actually on. Using the getCursorPosition, the screen to client, and this will give us the X and Y locations of our mouse. And we can then call the getHex command, as we did before, to get the X and Y locations using our short distance global variable. So if the hex number coming back is greater than 0, then we are indeed hovering over a hex button. So the very first time we enter this routine, the tooltip variable will be completely empty. So we can test that by putting an if command in. So there is the command if our hex is greater than 0. So we're testing the tooltip stored variable value against the array of tooltip text, using our hex number as the element of the array. So if these values are not the same, it means we're now pointing at a different hex, one we have not pointed at before. Then we can populate the tooltip with the one we're currently populating at. So once we've done that, we can then set the font, using the graphic set font command and the variable we set up earlier to point to our new font. We can use the graphic set position command to set the X and Y locations to where we are on the screen. We're going to set the colour foreground to blue and the background to yellow to give us a tooltip. And then we can quite easily use the graphics print command to print that tooltip out to the screen. However, what we'll need to do next is to handle the button clicks. Currently, we're handling the clicks on the left mouse button when the user clicks on one of the hex buttons in the main callback routine. I'm going to move all that logic into this function to keep everything together. So here is our button up event. And as before, we're getting the cursor position, we're translating that into our P, X and Y locations, we're getting the hex, and we're going through exactly the same logic as we did before, using the message box to send messages out to the user. So now that we have this in place, we can now take that logic out of the main callback function. So what I will do in here, rather than take the code out completely, I'm just going to comment it out. So before we run our application for the first time, let's go and declare this global variable at the beginning of the application. So here we have our global variable set up at the beginning of the application, one for our subclassing, one for the graphic handle, and I'm going to make the handle of the main dialog global as well. And in our main dialog function, we're storing the value of the handle of the dialog in the global variable immediately after we've created the dialog. So if we try running the application now, we have a dialog on screen, and when we move the mouse over, we're getting our tooltips. However, the tooltips are not disappearing from the screen, so we're cluttering up the screen with unnecessary tooltips. So we need to remove the tooltip once the user moves on to another hex button. So let's go in and make that change. One of the things we can do to make this much easier in coding is to use one of the graphics commands to store the graphics control as a string. So we're going to create another global variable to have our saved graphic bitmap. And there is the variable we're going to be using. We've called this graphic bitmap. We will save at certain points our graphic bitmap into that so we can easily restore it using a single line of code. So first we need to save our graphic when the screen is initially painted. So let's have a look at the main callback function. If we look at the paint event, after we've drawn the hex menu on screen, this is where we want to save it to our string. So there is the command, graphic get bits. This will take the content of our graphics control and save it to this global variable. So we now need to look at our subclassed callback function. In here is the logic to work out what we've actually clicked on. So in here we've determined that this is a new tooltip. So as this is a new tooltip, we want to restore the graphics control to its pristine state with no tooltips showing. So we can do that quite easily by using the graphic set bits command. It takes a single parameter, which is where we stored the bitmap. So let's try running the application now to see how that works. And there are our hex buttons. If we hover over them, we're getting our tooltip popping up. If we go to the next one, the first tooltip disappears and it goes on to the second one. So this seems to work quite well. However, the tooltip is staying there permanently on screen until you move to another hex button. Tooltips normally only appear on screen for a short period of time, so we can emulate that functionality in our application as well. So In this line of code where we print the tooltip, we want to wait for a short period of time and then remove the tooltip. So we're going to wait for 750 milliseconds, and then we will again call the setBits command to restore our graphic. So let's try running the code once more. And there is our code, and if we hover over any of the buttons, we're getting the tooltip appearing for a short period of time and then disappearing. This is giving us an ideal pop-up for a tooltip. It's on screen long enough to inform the user of the function of the button, and then it disappears, so it's not cluttering up the screen. So in summary, what we've achieved today are two things. We have created an icon for our application that will appear in the top left-hand corner of our dialog and also in the taskbar. Secondly, we have created tooltips for each of the hexagonal buttons on our screen. These pop up, albeit briefly, on the screen to give the user an indication of what function that particular hex button is to perform. And we're making use of the graphic get and setBits command to capture the entire bitmap of our graphics control and save it to a string variable. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.